Kai Yang was a student last year, and this is his project. So we'll be both talking today. So, do you want to say hi?
Hey, hi.
Sorry.
I'm Kai Yang, and I finished my honors at Vic last year under Ian, and this was basically my honors project. So we're going to talk about it here today and how we're going to expand it and stuff like that.
Cool. Okay. So we've already had a little bit of taste, which is great, about what is a honeypot and why you might want at home as well. Part of the context here is that it sort of fits in this model of heroic lone defender. So hardworking security experts who have to actually manage a lot of systems, perhaps are the only person in their organization and have another job as well, and they really want to slow down. They will give themselves time to react to attacks, basically is the idea. And this idea of the honeypot was introduced by Kate last year, as she mentioned. And the idea is that basically honeypots. So at Victoria, we've done honeypots for quite a long time. They're kind of fun. Often we're trying to get owned by attackers to understand what they're doing, and we want to look ideally as much as possible like a real web application or a real server so that it draws people in and we observe what they do. And of course it's a non-production asset, so it doesn't really matter if it gets taken over. We just put a wrapper around it to slow down the attacks that result to other people's networks from our own system. Now the idea of the honeypot is that it's a bit like that, draw people in, but also it's like one of these tar pits where various animals would get attracted to, fall in, then the predators come along and try to eat them, and then they would basically all die and leave interesting remains for us. So Libraia is one. They're also known as asphalt lakes, basically. And so then a Libraia network tar pit was a tar pit that basically said, hey, you want to give me a sin? Give me some more sins. Maybe I'll send some stuff back to you, keep you going. And I'll slow down basically your scans is the sort of idea behind it. So we combine the honeypot, the honeypot with the tar pit, bring people in. But we also have this idea that the honeypot is a transparent proxy in front of a real web application. So the idea is that you have a nice little filter here that really only affects the attacker. So the idea is that the attacker will hit our honeypot, and nice, well-behaved people who can generate well-behaved web requests basically go to the real application and just get what they want, is the idea of it here. So it's supposed to be completely transparent. But the unlucky attacker who's coming in gets given a set of doors behind which are the favorite vulnerabilities that they're looking for, is part of the idea. And possibly they actually get their own very special door with their own very special set of vulnerabilities. So they get the tiger or they get whatever else hides behind it. And then further, this is a great film, by the way. It's super creepy, right? Yeah, it's great. It's super creepy. So poor Ingmar Bergman, as we can see here, has got this really very unreliable husband who's making her think she's completely nutso, or nuts. And he does that by making her doubt her insanity this is a common technique. If you ever dealt with somebody in an abusive or obnoxious relationship who just says, don't know what you're talking about, or it's all in your mind, this is the kind of thing. And this is what we would really like to do to attackers under full ethical considerations. Yeah. So the idea is that we draw them in, we waste their time, we make them get tied up doubting their own sanity. And the part of the idea is that you are slowing them down so the next morning you have time to look at your logs and see what's going on and take action potentially. But also you're doing this kind of public good as well, in that you're diverting the energies of some people out there and keeping them tied up so they have perhaps potentially less time to attack other people's systems. So it's a general public good. So that was the setting for Kai's project, which is his project last year. So we decided we needed a name. We actually just recently came up for a name. Libraia was taken, but apparently Bermudez is the world's second largest asphalt lake, if you ever want to go there. It's a great place to holiday. And it also sort of rhymes with Bermuda Triangle, which is our other idea. So that was a later thing. So the project was to really give us a minimum viable product that we could keep building on in subsequent projects. And so we had the kind of model here of moving through levels of complexity. And we're sort of at the skateboard stage, basically. We wanted to create a solid building, solid foundation that we could expand upon. So we wanted to design something with a few software engineering principles, basic ones in there, wanted to have testing built into it, and we wanted to implement a set of vulnerabilities that would demonstrate the concept. And also just give us practice at using it so that we actually learn more about it ourselves and come up with better ideas in the future. It's cool. So what's the design? First of all, it's important to think about your users. So in this case, script kiddies, who get attracted by chocolates, apparently, which is cool. And the idea is that these script kiddies, in our view, will be using tools. And the OWASP project has a nice list of various black box testing tools which are out there. Some very automated, some less automated. When we were building this, we had in mind actually OWASP Zap as one because it's really nice. You run it against something. Oh, actually, we've got it up here. You run it against a site. It tries out scans for various vulnerabilities and gives you a report. And the idea is that we want the attacker, the script kiddie, to basically run this, come back with a list of here are things that you may want to investigate, and then they hopefully go down the idea is to take them down a rabbit hole there. And as you can see, it gives you a bit of detail about, I've never used this before. Cross-site scripting in this case gives you some idea about what's going on. You've actually injected a script there and so forth. The logic of the honeypot, as I said, the idea is it stands in front of a real web application and it captures requests that are basically malformed, attempts to determine you've got a vulnerability or not. Nice requests just go through as standard. So our little hierarchy here is that we receive the request, we look to see what's a known vulnerability, we then determine the type, and we generate some sort of fake response. Now, because we're looking at script kiddies, and this is the initial one, we didn't make the responses actually super realistic, just enough that it will trigger a tick at the moment. Future work could be to expand upon this. Otherwise, it's a legitimate request. If it passes, it's not a known vulnerability, gets passed on to the real web application, and the real response comes back. So, a simple idea. Now, I talked about tools and the fact we had Zap in mind because we could use it, which is good, and it provides good automated testing in a sense for the system. It's basically a unit test, a set of unit tests. But we want to follow a design approach that is more generic than building for a particular set of tools. And so we rely upon the OWASP testing guide, which gives you guidance for different vulnerabilities, basically a set of black box tests, which means that you can manually do it by hand if you want to validate. And that's what Kai actually did in his thing. So for instance, there's testing techniques for path traversal. This is one we looked at here. And we said, well, actually, if we assume that normal requests don't include path traversal instructions, basically, then it's probably going to be somebody probing us. And so we should handle it, and we should pass something back. Now, in this case, we pass back a standard response. But you could imagine that you could come up with something that apes various systems based upon your knowledge of what the attacker might be doing. So you might say, I'm pretending to be IIS today. I will give back a file that is appropriate to that. From a Unix system, I give back a password file to say, hey, look, you can get into my system. Later on down the street, if we want to gaslight people, we start to mess around. They say, I'm working with an IIS, and we respond and say, hi, I'm an IIS. But then we give them weird files on random chases. Or, even better, I'm just making this up now, is that we give them the password file, and then we create a system where you can actually log in, and that would be so cool. Yeah. Okay, so now I'm going to hand over to Kai. He's going to talk about his implementation.
Cool. Which one for next?
Yeah, that one just there. That's cool.
Okay. Okay, so I was the one who actually implemented the honeypot for my honors project. So I'll be walking you guys through how things work, like the whole nitty-gritty bits. So the honeypot was actually implemented as a Java servlet, and the servlet was deployed in a Tomcat server for testing. Now, Java isn't really like your first language of choice when you're looking at PHP exploits, but the reason I chose this was because if an attacker was assuming it was a PHP-based web app, then our Java-based honeypot would likely be invulnerable to any of the actual exploits they used against it. And also, I was doing another project using Java at the same time, so this one lined up perfectly. So here we have the structure of the honeypot. So we essentially have the main honeypot app. Whoops. Yep. The main honeypot app over there, it's got all the methods like do get, do post that handles the incoming requests and performs detection by using these rule classes. So you're going to need one rule for every single exploit that you want to detect. And what this rule does is it has a detect method that determines whether or not an incoming request is actually an exploit. If it isn't an exploit, then as Ian has said, we hand the packet over to the legitimate web page. But if we see that it is an exploit, then the generate response method is called, and this basically generates our fake response. Now, this can be customized further. As you can see, there's 3 examples of rules that we used with SQL injection, cross-site scripting, and path traversal. And in the path traversal, we actually loaded a dummy password file to essentially mess with people. Okay, and here we can see a portion of the path traversal rule. So how this rule works is, as Ian has said, it detects path traversal operators in the parameter values. So if any of these things are detected, then we know this isn't a legitimate request. And we return them this password file here. Now, this was a dummy file with John Doe's and stuff. So as we have said, it is not the most convincing password file that one could find out there, but it is enough to generate a positive response on Zap and show that our thing appears to be vulnerable to something at least. Okay, and here we have our gaslighting system. So we decided to basically give each attacker their own view of the program. So if we have 3 vulnerabilities loaded, we have 6 possible combinations of these vulnerabilities, as you can see here. And we had a small algorithm that basically took the IP address as a number and performed a modulo operator on it with the number of combinations, so that each set of, or each IP can get their own set of exploits pretty much. This makes coordination between hackers a lot harder, since we could have 2 hackers who are sitting right next to each other, but they might have different IPs and they'll have a different view of the program. So hacker A says, hey guys, this thing's vulnerable to cross-site scripting, and then hacker B says, no, it doesn't have a cross-site scripting weakness. I can perform path traversal on it. So this will make it pretty hard for them to work together to find what our thing is actually vulnerable to, which is none of them. And importantly, this makes the entire honeypot stateless, which is good because we don't have to maintain any sort of a database mapping attackers to exploits. And it means that, for example, restarting the honeypot or having a crash or something will not affect future incoming requests. Oh, and the demo goes here.
Right. Hopefully.
It's on the films and TV.
Yeah, I'm not sure how this will work. Oh, okay. Oh yeah, I have to drag it across to the other screen.
Oh,
do you want me to?
Yeah, I should.
Yep. Do this. Da, da, da. Okay. Oh. I'm sure there's something.
Does it seem to pause and play or not?
Ah, should do. Try it.
Yeah, okay. So we have 2 cases of the honeypot being run. This is the first case in testing mode, where basically every single exploit is active and displayed to all users. So yeah, it's being run from Eclipse right now. Yeah, so as you can see here, this is a version with 4 exploits actually, but Zap has found 4 different exploits available in the honeypot. So this will pretty much encourage attackers to come and explore them further, which goes back to our whole wasting their time thing. And if we expand one of these. provides more detail on what kind of exploit may be possible. So we were faking SQL injection by faking typical SQL errors that would be returned from a failed injection attempt. So that's what is done here with the use select statements have a different number of columns. So by giving these kind of messages, the attacker will hopefully use more sophisticated tools and keep trying to probe our system. And this is a gaslighting case. This was a case, we'll call it, I guess, a real-world usage, if you can even call it that, where we have enabled the whole gaslighting system, and the shown exploits are tailored to the attacker. So this is the exact same honeypot, just with the test mode set to false. So as you can see here, even though it's the same system, only 3 exploits are shown this time. And I guess if you change the IP, then you might get even fewer. So back to presentation. So this is our minimum viable product, Mark II. And our future goals are to hopefully, well, first of all, slow them down further. We're going to implement more vulnerabilities in, as well as we would like to deploy a full site structure behind the honeypot. For example, with a real web application and something useful to actually protect. And it is hoped that a further expansion of the gaslighting system will make attackers almost addicted to exploiting our system. So kind of like a reward system in common game theory, where we reward them for better and more sophisticated attacks while never revealing our real information. So the more time they spend on our honeypot, the less time they have to break into actually useful stuff. Cool. Yeah, and this was our future of testing the idea further. We'd like to deploy this as a real web application onto a public server so that we can hopefully bait real hackers into giving up their secrets, I guess. And yep, we want to learn from their methods and find out ways to stop them. So are there any questions? And cool. You can play with this stuff on my GitHub. We're going to move it to a team GitHub though, right?
Yeah. And a proper name. Yeah, rename it. Very cool. Okay, great. Thank you.
Thanks.
Cheers. Cool. So if anybody's interested in talking more about it, please come down or catch us at lunchtime. Thanks.